I'd like to give you an introduction to the matrices we will use. We use a matrix basically as a scorecard, and it's important that we get this right because this is what sets up our research. So the examples that you have in your text material show very generic criteria. This is where we make our criteria hard. So if you look at the problem matrix or the solution matrix, the root cause matrix, you'll see that there are fairly generic criteria that are used. One of the examples has to do with accidents in the parking lot. There are others. When we use a matrix to define a problem, it is a problem matrix. When we use a matrix to determine root causes, it's a root cause matrix. Solution matrix, of course, would be when we're trying to come up with solutions. And there is one a little bit more advanced called a criterion rating matrix. And the difference between that and all the other matrices is that each criterion is defined very specifically. So if cost is one of the criteria, we will define it as to what range is acceptable. So if we use a scoring mechanism of 3 is best, 2 is medium, and 1 is low, then 3 would be, for example, anything under $10,000. 2 would be $10,000 to $15,000, and 1 would be greater than $15,000. And you'll see that in the illustrations, that each criterion is defined very specifically. That's best used on the solution side. The other matrices typically use what's called attribute data. So it's either or, yes or no. For example, can we fix this? That would be an attribute question. And let me take a little bit more time to explain that. Data generally shows up as attribute data or variable data. Attribute data means it possesses that characteristic or not. Let's say I ask you to count the number of men who walk through the door. So you'll look at each person that comes through and you'll make a determination and make a count based on the number of men or women, if that's the case, who walk through the door. That's attribute data. Variable data is, as the name implies, a large variation. So let's say I ask you to write down all of the hair colors that walk through the door, or the different colors of jeans or pants that people wear. That would have a great deal of variation. And you'll see as you go through this a little bit more that that variation can actually be harnessed and help us define problems very powerfully. So in a problem matrix, a root cause matrix, or a solution matrix, typically these are attribute data. It could be yes or no, or very simple ranges. In the criterion rating matrix, we get very specific about what each criterion means, and we score it. So in this case, as you see this simple matrix I have set up, we'll have our criteria listed along the top, and I'm only using numbers because I just want them to represent the criteria. So this could be cost, and can we fix it, etc. And so in terms of cost, maybe we would say it would be less than $5,000. So yes, no, and yes. Can we fix it? Yes, 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 no, yes, and so on. A couple of things to point out. These criteria that you set along the top here are what you're going to research. So if we say we're researching restaurants and cost is an issue, it's one of our criteria, then we would have to go to those restaurants and find out what the costs are, and then we come back and plug that information back into our matrix. That's where it becomes a scorecard. So the matrix both sets up our research and records the results of our research. So if our criteria are garbage, the results we'll get are garbage. If they're too generic, they're not very specific, then what we'll get is non-specific information that will make it very difficult for us to make a decision. So we want to be very thoughtful about coming up with the criteria along the top here. And I like to see 5 to 7 hard criteria in a matrix. That gives me a pretty good look at the problem, and if I'm asked, how did you arrive at that recommendation, I can show, here's how all of the ideas stacked up against each other. We used these criteria, we weeded those out, this is what survived. Ultimately, we plugged them into a matrix and evaluated them on these hard criteria, and this is the result that came up. So it becomes a very thorough, well thought out, and provable or defensible recommendation that comes out of these matrices, but only if our criteria are accurate or they're specific enough and they're relevant. So it's important that we take some time to think about what criteria we're going to use. So just in a nutshell then, our remaining ideas are listed along the top, along the side. Then our hard criteria are listed along the top, and hard means they're specific. And then we go out and do our research, and we come back and plug that information into our matrix. And when we see how all of them stack up against each other, we then can make a decision about what to do with them. Now, if something makes it to the matrix, let's say these are all root causes, all of them probably have some bearing on the problem. So we might deal with all of them, probably will. Or it may be that G was so expensive that's not within our team's purview, but the executive director could actually do that. So this tells us, where do we start? Where are the priorities? Are there some early wins we can gain here? And how do we prioritize going after this? If these are solutions, same kind of thing. How do they stack up against each other? What are the solutions we should do first, and what should come later? All of this is reflected, again, on the criteria that we establish. We set criteria, we go out and research each one of those, we fill in the box in our matrix to say what the results were, and that then gives us a large picture of what our decisions ought to be. So that's a very simple introduction. There's a lot more explanatory language in the text material, but I hope that that verbal explanation will give you a little bit more insight or clarity on how we use a matrix.